Hello, everyone. Welcome to SAT Math Question of the Day, where we have Professor Emeritus Seth Chaiken from University at Albany and his brother, hey Seth, Joel Chaiken, trying to help you understand how to do math SAT questions. More importantly, how to approach them. Here's today's question. What's the sum of all the values of m that satisfy that equation? So, this is I don't know what to say about this equation. My personal attitude is either you know how to do this or you don't. This is what I would call a formula type question on the SAT. Maybe not to say formula, but more of a relation. Either you know, either you understand how to do this or you don't. If you don't know how to do this yourself.
I think though, that you also need to recognize that that there's another name given for one of the terms of the problem, and that you might have remembered how to solve this problem in terms of one name, but not in the other name.
That's true.
So
That's
please
true.
remind them what it means for a value of m to satisfy an equation.
Absolutely.
Is there another word of?
Yes, of course. The value is m
What
or
is
the
that
roots.
word?
M are the roots of the equation. The roots of the equation. Yes. Yeah. Right. If you have most of the time,
these are the roots.
Right.
Of the equation.
Right. And traditionally, you see
Those are the values, are the roots, and the question is about the sum of the roots.
Absolutely.
Which is the same thing as the sum of the values that satisfy the equation.
Absolutely right.
So
that's right.
Now you might know how to do it in terms of having learned what the sum of the roots are, or you might know how to solve it in terms of knowing what the sum of the values that satisfy the equation is.
Right. Well, most people will know the quote sum of the roots of a quadratic equation. That's most people. That's the way most people learn it. Yeah. So
it's important to take away from here with studying SAT questions that they'll sometimes use different words, and you have to connect the words they use in the SAT problem, like value of m that satisfies equation. You have to connect that with the word that you have learned, which is root.
Exactly. That's one of the main points of SAT. SAT tests generally test how much you understand the material. And you have to understand that the values of m that satisfy the equation that equals 0 are the roots. SAT questions require some understanding. Yeah, you're right, Seth. They easily, you see this all the time, where they can take a synonym and really require you to understand something. Yeah. So that being said, you have to know the formula then for the sum of the roots of a quadratic equation given the equation. Most of the time you've seen it this way: x squared plus bx plus c is equal to 0. I don't know. Actually, that's not true. You've seen it this way: ax squared plus bx plus c is equal to 0, and you're supposed to know the sum of the roots of the quadratic given this. There is actually a formula that tells you what the sum of the roots are of this equation. So
what's the formula?
Well, the thing is, I don't like to memorize formulas, and I prefer to remember the formula this way. If you have an equation like this, ax squared plus bx plus c equal to 0, the sum of the roots is negative b, and the product of the roots is product of roots, right? Sorry, is c. Okay, that's the way I remember it. I don't like to remember with the a. Okay, I hate memorizing formulas, so I try to memorize as simplest, as basic formulas as possible. So this is how I remember. This has to be a leading one. And in our case, it's not that hard to make that a leading one. You just divide out the two. I don't remember the formula with the leading a. It's probably something over b or something, over a, but I'm not going to remember.
Oh.
Okay, I'm only going to remember this one. because it's easier and simpler.
Uh-huh.
So then, knowing this, that you apply the formula. You divide by 2 because you want to make it this way. So you could always divide a 2 out. I mean, you could always, in this case, you could factor out a 2. Sorry, factor out a 2. So you get m squared minus 16m, no, minus 8m,
No.
minus 8m, plus 4 is equal to 0. If you want to be cool, you could divide it 2. You divide everything by 2, right? Because 0 divided by 2 is 2, and now you're left with m squared minus 8m plus 4 is equal to 0. And then you see the roots are 8. I mean, it's negative b. B is negative 8, which means the roots are, some of the roots are 8. I hate this question. I hate this because...
Okay.
I hate this question because yes, you're right, Seth. The first thing to do is to understand what roots are. That's a good question. But what I hate about this question is it forces you to know a formula.
Yeah.
And,
Okay. Let's suppose. How about maybe erase? Could you erase what you wrote?
Sure, I could go like this. Look at this. Isn't this cool?
Yeah. Get rid
erase
of all.
everything.
Yeah. Do undo.
Okay. Now I know
especially the formula for the sum of the roots of the equation.
I'll leave a regular quadratic.
Yeah. Leave the regular quadratic.
Okay, let's see how you do it.
Suppose you forgot this formula for the sum of the roots.
Can I answer that question?
Yes.
Skip the question. Skip
No.
the question. Go to another question.
No. Suppose you forgot that formula, but you did remember the formula that the roots equal, and there are 2 of them. You might remember this formula.
Yeah, that's true. You're right.
Suppose you
The
remember
quadratic
this formula.
Right.
Right. Of course, so there are 2 of them. One is given by the formula with the plus sign used, and the other with the minus sign used. Suppose you have this formula.
Right.
From this formula, well, let's suppose what you could do is substitute the 2, the minus 16, and the 8 into this formula, get the roots, and then add them.
That's a really good idea, actually.
Right. So let's try that.
Yeah. Okay.
Let's try that. B squared. Ouch! I don't want to compute B squared. 16 squared is a ridiculous number.
True.
And then what's 4AC?
Forget it.
A is 2. C is 8. That's 16. Times 4 is 16 times 4 is 64. So we have 16 squared. Oh, I don't want to do this. It's a big mess. This is going to be a mess.
Right. Of course.
Mess. But suppose I took the formula. It's easy to substitute B and A. So I'll use black. I'll use red to substitute B and A. B is minus 16.
Okay.
Okay. And of course the formula has a minus there. A is 2.
Right.
A is 2. And it's easy to figure this out. So it gets the roots are 16 plus or minus something that it's a real mess, divided by 4.
Right.
Now, the sum of the roots equals this thing with a minus choice. Sorry, this thing with a plus choice, plus this thing with a minus choice.
Right.
Same mess.
Right.
Well, we have this ugly numerical expression in the square root, And here it appears added. Here it appears subtracted. When you add them, the two square roots cancel.
True.
And so what you get is 2 times 16 over 4.
I'm just going to move the
which
screen
is
a little.
16 over 2.
Yep.
Which is 8.
Which is 8.
So if you didn't remember that the sum of the roots is minus b over a, but you did remember the quadratic formula. If you wrote the quadratic formula down, you might think of adding the two roots together without wasting time computing or simplifying the number in the square root.
Right.
And that would give you the answer.
That's really
don't give up that quickly. If you're relying upon having memorized formulas that tell you about roots, if you forgot the formula for the sum of the roots, you might use the formula for the two roots together, and then take that formula and take the two roots that the formula gives and add them to get the sum of the roots.
Right. Right. Yeah, that's really smart. That is actually really smart, but you have to remember the quadratic formula.
Yeah.
Yeah. Now, while you're doing that, what happens if you ask for the product of the roots? Are you then going to be multiplying this thing? You're then going to be multiplying this. That's
if you multiply it,
and then they cancel.
If you multiply it, what you have is a multiplication of the form something plus something,
right,
multiplied by something minus something,
right,
which is the first something squared minus the second something squared.
And that has to do with
the second something is the square root. So the squaring of the square root gets rid of the square root, and it will simplify out.
Yeah. But no, if you do a plus b and a minus b, that's the difference of two perfect squares. So it's a squared minus b squared.
Yeah, and then of course, I don't want to use a and b because a and b already appear in the problem.
Yeah, but okay. So so if you forget that, you could use the quadratic formula to figure out what the product of the roots are. Yeah, that's actually a very smart thing.
Yeah.
Yeah, that works really well.
However, the thing to take away is that when you study for the SAT, make a note of the basic facts that were taught in your classes that are going to be tested.
Right. Yeah, absolutely. Yeah.
Okay.
So I think we're done with this. There's one other little tiny theorem. There are two things we should do really, as our little after party. Basically how to understand where that thing even comes from and also the theorem that I hate even more than this one, which is the quadratic remainder theorem, right? That's another one you should know for the SAT. Not for this question, but you should know it. We should go over that quickly. So let's bid everyone goodbye who doesn't want to stay for those things. Please like us, dislike us, comments, everything. We welcome, we encourage all comments. We need to know how we're doing so that we can continue to help you. Okay, have a great day, everyone. And we're just going to talk about the remainder theorem, which is the third of the theorems that you should know, facts you should know, and then we'll try to very quickly see where that sum of the roots also comes from, product of the roots also comes from. Okay, so ready? Is that okay? Can we start?
Okay, let's go.
So let's say you have a polynomial. But we'll do this quickly because that has to go in a few minutes. We have a polynomial 3x squared plus 4x minus 9, and you want to know if you divide this by x minus 4, you get some sort of mess. What is the remainder? Now, again, you do this in 11th grade math, and sometimes the SAT requires you to know this. So the answer is this is f of x, okay? This thing here is f of x, right? So the remainder is just f of 4. You take the root here, that makes it a 0, that makes this bottom denominator a 0, and that's 4, and you shove it in there. So this is 3 times 4 squared plus 4 times 4 minus 9. Another one of these things. You either know or you don't. Any comments, Seth?
Yeah. Let's see. Let's see. Yeah, if you divide f of x by x minus 4,
right?
And what you're trying to do is find a quotient, which will be a
right,
which will be a polynomial in x times x minus 4,
right,
plus a remainder,
right.
and the remainder is a number. If you plug in f of 4, you get
Oh my God, that is
q
so
of
brilliant.
4 times 4
Zero.
minus 4
Zero.
plus the remainder.
Oh, that is so cool. I
4
never saw
minus
it.
4 is 0, so
Yeah,
you don't care what the
Look at
quotient
that.
is.
Wow.
And that proves that proves this rule that Joel reminded you of.
I never saw that before.
This is a proof of the remainder theorem.
Wow, that is the coolest thing. That's the coolest thing I saw today.
Yeah.
Great. Okay. Wow. Okay. And then very quickly, this whole thing about the roots. If you have an equation, x minus 3, equation. If you have these two these, and you multiply them, you get x squared minus 7x plus 12 equals 0. The roots are 3 and 4. You can sort of see, just a little whatsoever. When you loose about
this
stuff
is how
like that.
x times minus 4
see
gives you sum of the negative 7.
Yeah, right.
And minus 3 times x gives you the rest of negative 7.
Right.
It gives you x times minus 4 is minus 4x, and minus 3 times x is minus 3x,
right?
Which is minus 7x.
Right. Yeah. And then so this you could sort of see where the sum of the roots comes from.
Yeah.
That does,
and
it
also shows you where the product of the roots comes from.
Yeah.
The product of the roots is 3 times 4.
Right. Yeah.
And that is the term, the zeroth order term, the constant term.
That's
3 times 4 equals 12.
So what this does
the two minus signs, are multiplied to give a plus sign. So that's why you get a plus here.
Yeah, this does bring up a point. Let's say you sort of remember that there is a relationship between the sum of the roots and the product of the roots, and you don't really quite remember it. Bring up an example that you could do right on the spot. X minus 3 times x minus 4, and then just do it. Because you have experience doing that. X squared minus 7x plus 12. And then you see, the roots are 3 and 4. You see the pattern? 3 plus 4 is negative 7. And that'll, if you remember a little bit that there's some sort of relation, but you don't quite get it right, and you're not sure about that negative sign, then just make a little example for yourself on the side. And that'll remind you. That should click in your head. Oh, yeah, now I remember. Okay? So that's another way to do problems. If you don't quite remember something, bring up a simple example that you sort of used to know, and then that'll help you. Maybe also draw your memory.
Yeah.
Okay.
So no PQ.
Yeah.
Yeah. So and you could do it with algebra. It's just as easy to do it with
but nobody's
with algebra. P and Q are represent the roots.
Right.
And then doing it with algebra, you get that the coefficient of x is minus p minus q, which is minus p plus q.
Right.
And the coefficient of y is minus 1 times minus 1 times p times q, which is pq.
Right.
Okay. All right. I think we beat this. We've done this one.
Totally beat this to death. So
Yeah.
thanks everyone for sticking by, and have a great day.
Okay. Thank
Bye-bye.
you.
Bye.
Bye-bye.